Hi friends, this is Teach and welcome to a new video. In this video I'm going to teach you that what is a diode and how does it work. So let's get started. This is a diode, which we call it also a rectifier diode. What does it do? It rectifies a current. We got many types of diodes, which this is one of them. This one, this one, this one, this one, this, and this. We got many other types, but I just had these ones. Alright, let's talk about it. The symbol of a diode, which we use it in a circuit diagram, is this one. It's an arrow, a line, and and these two lines. What does it mean? This arrow shows the current flow, means current flows from this, and this is positive, this is negative, from positive to negative, but not negative to positive. This line means the blocking of the current. It means it blocks current from negative to positive. But how does it block the current when you connect it vice versa? If you take a look, in a diode we have a line which is the negative pin and the other one is the positive pin. When you connect the current and flow it from positive to negative, it flows the current and has a drop voltage about 0.7 volts because of the resistivity of the diode. But if you connect it vice versa, it means you connect positive to negative and negative to positive, it blocks the current. Actually, it shows a super high resistance which blocks the current, or lets a super tiny current to flow. We use it in rectifiers, which I have the video too, for full bridge rectifiers and many circuits, though any circuit which you need to use it because you don't want a current to flow in both sides. But this is a super common diode called 1N4007. It's the most common one. The most voltage which it can flow is 1000 volts, and the maximum current is 1 amps. We got some other types like this one, which it's a diode just like this, but and this one is 1000 volts too, but instead of 1 amps it is 8 amps, the maximum flow current of this diode, because the code is 5408. This 8 shows the maximum current. The other type is this one, which is like a transistor. If you don't know what is a transistor, watch my video. It has 3 pins, but if you see it, it's 2 diodes. It means between these 3 pins, if we call them pin 1, 2, and 3, it's something like this. It lets the current flow through 3 to 2 and 1 to 2, but not other sides. It means not 1 to 2 to 1 or not 2 to 3. We use these ones in switch mode power supplies. The other type is this one, which we call it a bridge rectifier. It has 4 pins, but also it has their diode. It's diode, not something else. But why it has 4 pins? Because inside this one there is something like this. There's something like this. This is negative, this is positive, this is alternative current, and this is AC2. If you take a look, you see the AC between these two pins. If you see the longer pin, which it has a cutted part right there, it's positive pin, and this one is negative pin. But what does it do? This is actually a bridge rectifier, which you use it on rectifiers, anything which rectifies the AC voltage, and it actually converts AC voltage to DC voltage. What does it do? We put a power source right here, and when you connect the power source, because the input is alternative current or AC, it doesn't matter how to connect it. It's like just when you plug something in, which is not important that you connect it like this or this one. So the current comes in and it converts AC to DC. But how? We have a sine wave here. This is a sine wave. For example, imagine that your voltage is about, for example, 12 volts. This is positive 12 volts, and this is negative 12 volts. We have a sine wave which is like this. We have a sine wave which is like it. This is 1 hertz. If you don't know what is 1 hertz, watch my previous video, which was about a multimeter. This is 1 hertz, alright? An AC voltage in some countries, AC voltage of some countries is about 50 hertz, and some other countries is 60 hertz. Not too much matter. Anyway, and yeah, that's it. But what does it mean? As I told you, this is 1 hertz. During this 1 hertz, the voltage, imagine that this is one of the pins and this is the other pin. The other pin goes up to 12 volts, comes down to 0, also down to negative 12 volts, and then done. So when you connect it to this one, imagine firstly upper is positive and the down is negative. Positive comes through this one, comes here. This part actually blocks the voltage because it's positive and can't through negative to positive. So it flows through this one and goes to the positive. And the negative comes here. This blocks it because it just should be positive. So flow through this one, it goes to the negative. Then imagine that this one is negative and this one is positive. It does it like that too. The positive comes through the arrow to positive, and negative comes, it blocks it, so it comes from here, and this is negative again. So it connects this sine wave to something like this. But how to convert this one to DC voltage, I'll explain it in my next videos. So this is a bridge rectifier. Next one is a diode. It's also a diode, but we call it LED, which is light emitted diode. But what's the difference between this one and other ones? It's a diode too. It means the current flows through just one pin to other pin, not the other one to this one. But there's a difference, which it makes light. This symbol is like the diode, but a little bit different. It has 2 arrows like this. It means it has light. If you see it, when I connect positive to negative and negative to positive, it makes light. But if I connect it vice versa, positive to negative and negative to positive, there's no current because it blocks the current. It doesn't let current flow through it. Next one is a 7-segment, which is, we call it bar graph LED. But what is bar graph LED? It has a small difference with these LEDs. It means you should make your voltage to set to its voltage to be turned on. If it's a little bit lower, it doesn't turn on. What is 7-segment? It's actually 1, 2, 3, 4, 5, 6, 7, and this point is 8. There are 8 LEDs, and they have a common pin. Some of them are common cathode common or positive or anode common. Anode is positive and cathode is negative. Cathode pins are actually these middles, this middle one, the other middle one, and other 8 pins are positives of the others. For example, if you want to find out that it's common negative, the negative is common or positive, we just pull out the middle pin, we connect the positive, and then we connect the negative to this one. So it means it's common positive, or positive common. When you connect it like this, it's just that. It's on voltmeters or clocks or anything else. The other one is a power LED. That's an LED too, but it's too much powerful. But what's the difference? Through this LED, we should put a voltage about 3 volts, and the current flow is about 10 milliamps, which it means that's not too much. But for this one, we put 12 volts, and it's about 1 amp, which is too high, and it has too much light, so it overheats. And for protecting it from burning, we should use a heatsink, which is made of aluminum and doesn't let it burn. The last one is actually a flyback diode. It's like other diodes too, but there's a small difference, which is the maximum voltage through these flyback diodes is not 1000 volts or 2000 volts. For example, this one, maximum voltage through this one is about 15,000 volts, but the maximum current is too low. Maybe it's about 100 milliamps. That was it. That was the explanation of diodes. Thanks for watching, and goodbye.